Have you ever looked around and wondered if this is all there is? Have you ever questioned the very nature of your existence, pondering whether the world around you is as real as it seems? What if our reality isn't real at all? What if everything we perceive, every interaction we have, is part of an elaborate illusion? What if we are living in a giant computer simulation? Imagine a world where every building, every tree and every person is nothing more than a complex line of code. It might sound like science fiction, but some physicists and philosophers believe it could be true. They argue that the advancements in technology and our understanding of the universe point towards this possibility. The idea that our universe is a simulation is known as the simulation hypothesis. This theory suggests that a more advanced civilization could have created a simulated universe so sophisticated that its inhabitants, us, are unaware of its artificial nature. It's a mind-bending concept that makes us question everything we thought we knew about reality. If our world is a simulation, then what does that say about our place in it? The simulation hypothesis suggests that what we experience as real is actually a sophisticated computer program. Every sensation, every emotion, every thought could be pre-programmed. Our senses, emotions, and even our memories could all be lines of code. This raises the question, if everything is coded, do we have any control over our actions, or are we simply following a script? It's a dizzying thought, like something out of the Matrix. The idea that our lives are not our own, but rather part of a grand design, can be both terrifying and fascinating. But unlike the movie, there might not be a way to escape this simulated reality. Or is there? Could there be a way to break free from the confines of this digital existence? The possibility of living in a simulation raises profound questions about our existence. If we are in a simulation, who or what created it, and for what purpose? What does it mean to be human if our experiences are manufactured? If our thoughts and feelings are not our own, how do we define our identity? What are the implications for our understanding of free will and the meaning of life? If our choices are predetermined by a program, do we truly have free will? These are not easy questions to answer. They challenge the very core of our understanding of reality and our place in the universe. But exploring them can lead us down a fascinating path of philosophical and scientific inquiry. It opens up new ways of thinking about our world and our existence, pushing the boundaries of what we know and what we believe is possible. The simulation hypothesis proposes that we are living in a digital world, one that is meticulously crafted and controlled by a more advanced civilization. This idea, while seemingly far-fetched, has gained traction in both scientific and philosophical communities. Imagine a world where every detail, from the grandest galaxy to the tiniest atom, is part of a complex program. This world, our world, could be a sophisticated simulation created by beings far more advanced than us. Think of it like a highly advanced video game, but on a scale and with a level of detail that we can barely comprehend. In this game, we are the characters, living out our lives, unaware of the true nature of our existence. The characters in the game, that's us, believe their world is real. They go about their daily routines, form relationships, and face challenges, all while being oblivious to the fact that they are part of a digital construct. They have experiences, relationships, and even struggles, unaware that they are just lines of code in a program. This raises profound questions about the nature of reality and our place within it. The simulation hypothesis isn't just a modern idea. Throughout history, philosophers have pondered the nature of reality and whether what we perceive is the true essence of existence. Philosophers have been grappling with the nature of reality for centuries. From Socrates to Descartes, many have questioned the reliability of our senses and the possibility that our perceived reality might be an illusion. Plato's allegory of the cave is an early example. In this allegory, prisoners are chained in a cave, only able to see shadows cast on the wall by objects behind them. In this allegory, prisoners chained in a cave believe that shadows on the wall are real. They have never experienced the world outside the cave and thus accept the shadows as the only reality. They have never experienced the world outside the cave. This allegory serves as a powerful metaphor for the limitations of human perception and the potential for a deeper, hidden reality. This allegory explores the limitations of our perception and the possibility that what we perceive as real might be an illusion. It challenges us to question the very fabric of our reality and consider the possibility that there is more than meets the eye. The simulation hypothesis takes this idea a step further. It suggests that our entire universe, with its vastness and complexity, could be a simulation running on a supercomputer. This supercomputer, operated by an advanced civilization, could be responsible for every aspect of our existence. It suggests that our entire universe, with its vastness and complexity, could be a simulation running on a supercomputer. This idea opens up a myriad of possibilities and questions about the nature of existence and the potential motivations behind such a simulation. But why would anyone create such a simulation? The reasons could be as varied as our own motivations for playing video games. It could be for entertainment, to study the development of civilizations, or even as a way to preserve a civilization that might otherwise be lost. The reasons could be as varied as our own motivations for playing video games. Perhaps it's for entertainment, research, or even as a way to preserve a civilization. The possibilities are endless and open to interpretation. As we continue to explore and understand the universe, the simulation hypothesis remains a fascinating and thought-provoking idea. It challenges us to rethink our understanding of reality and consider the possibility that we are part of something much larger and more complex than we can imagine. The seeds of the simulation hypothesis were sown long before the digital age, in the minds of ancient thinkers. Ancient Greek philosophers like Plato pondered the nature of reality and the limitations of human perception, questioning what is truly real. Their ideas laid the groundwork for questioning the true nature of our existence and the world around us. Fast forward to the 21st century, and philosopher Nick Bostrom brings the simulation hypothesis into the digital age with a modern twist. In his 2003 paper, Are You Living in a Computer Simulation? Bostrom argues that at least one of the following propositions must be true. 1. Civilizations like ours go extinct before reaching a post-human stage. 2. Post-human civilizations have little interest in running simulations of their ancestors, finding it unimportant. Or 3. We are almost certainly living in a computer simulation created by advanced beings. Bostrom's argument hinges on the exponential growth of computing power and its potential. If civilizations survive long enough to create technologies far exceeding our own, they could create incredibly realistic simulations. These simulations could be so sophisticated that the inhabitants, like us, would be completely unaware that they are living in a simulated reality. The simulation hypothesis gains traction from some of the bizarre findings in physics, particularly in the realm of quantum mechanics. This hypothesis suggests that our reality might be an artificial simulation, much like a highly advanced computer program. The peculiarities observed in quantum mechanics often seem to support this idea, as they defy the conventional laws of physics that govern our macroscopic world. Quantum mechanics is the study of the very small, the world of atoms and subatomic particles. At this scale, particles behave in ways that are completely different from the objects we interact with in our daily lives. The rules that apply to the quantum world are not only strange but also counterintuitive, challenging our understanding of reality itself. And it's a world that often defies common sense and our everyday intuition. For instance, particles can exist in multiple places at once, and their properties can change simply by being observed. These phenomena are not just theoretical, they have been demonstrated in countless experiments, leaving scientists both fascinated and perplexed. One of the strangest aspects of quantum mechanics is the idea of superposition. This principle states that a particle can exist in multiple states simultaneously. It's only when we measure or observe the particle that it chooses a specific state. This concept is so bizarre that it has led to famous thought experiments, such as Schrödinger's cat, which is both alive and dead until observed. This means a particle can exist in multiple states at once until it is observed. Imagine flipping a coin and having it be both heads and tails at the same time until you look at it. This is not just a quirky idea, it has profound implications for our understanding of reality and the nature of existence. It's like a coin spinning in the air, it's neither heads nor tails until it lands. But in the quantum world, the coin doesn't just land, it exists in a state of both heads and tails until someone observes it. This challenges our very notion of what it means for something to be real. This inherent uncertainty in the quantum world suggests that reality might not be as fixed and definite as we perceive it to be. The famous Heisenberg uncertainty principle states that we cannot simultaneously know both the position and momentum of a particle with absolute certainty. This introduces a level of unpredictability and randomness into the fabric of reality itself. Another mind-boggling concept is quantum entanglement. This phenomenon occurs when two particles become linked in such a way that the state of one particle is directly related to the state of the other, no matter how far apart they are. This connection persists even if the particles are separated by vast distances, leading to some truly astonishing implications. This occurs when two particles become linked, even over vast distances. If you measure the state of one particle, you instantly know the state of the other, regardless of the distance between them. This instantaneous connection seems to violate the principle that nothing can travel faster than the speed of light, adding another layer of mystery to the quantum world. When you measure the state of one particle, you instantly know the state of the other, no matter how far apart they are. This phenomenon has been experimentally verified and remains one of the most puzzling aspects of quantum mechanics. It suggests that information can be transmitted instantaneously, a concept that has profound implications for our understanding of space and time. Einstein famously called this spooky action at a distance. He was deeply troubled by the implications of quantum entanglement, as it seemed to contradict his theory of relativity. Despite his reservations, numerous experiments have confirmed the reality of entanglement, forcing scientists to reconsider the fundamental nature of reality. Could this seemingly impossible connection be evidence of a simulated reality, where information can be instantly transmitted across the program? If our universe is a simulation, then the rules governing it might allow for such instantaneous connections, much like data being transferred within a computer system. This idea opens up a whole new realm of possibilities and questions about the nature of our existence. And then there's quantum tunneling, where particles can pass through seemingly impenetrable barriers. This phenomenon occurs when a particle encounters a barrier that it seemingly shouldn't be able to cross, yet it does. Quantum tunneling has been observed in various experiments and has practical applications in technologies like tunnel diodes and the scanning tunneling microscope. It's as if you threw a ball at a wall, and instead of bouncing back, it just appeared on the other side. This defies our everyday experience and challenges our understanding of how particles interact with barriers. Quantum tunneling suggests that particles can take shortcuts through barriers, a concept that has far-reaching implications for both science and technology. These bizarre quantum phenomena challenge our fundamental understanding of the universe and leave the door open for the possibility that our reality might be something stranger than we can imagine. As we continue to explore the quantum world, we may uncover even more mysteries that could reshape our perception of reality and our place within it. The journey into the quantum realm is just beginning, and it promises to be a fascinating adventure that could change everything we thought we knew about the universe.